In this video, we examine a fascinating hypothesis that challenges conventional ideas about physics and the nature of consciousness. The central theme of our discussion is the potential for human thought to function in a manner that might allow for the exchange of information faster than the speed of light. While the speed of light is widely regarded as an unbreakable barrier for physical phenomena, recent investigations into remote viewing and the properties of human consciousness have prompted new questions about the limits of information transfer. This video explores whether consciousness, as an abstract and internal process, might bypass the restrictions imposed by physical laws. We begin by outlining the key concepts that underpin this discussion. We delve into the fundamental principles of physics, including Einstein's theory of relativity and the role of the speed of light as a universal constant. At the same time, we explore evidence from quantum mechanics, such as entanglement, which shows that certain processes in nature can occur instantaneously over vast distances. By juxtaposing scientific evidence with emerging studies in consciousness research, we aim to present a balanced and thought-provoking perspective. In our journey, we consider how memory, perception, and the abstract nature of thought may provide a framework for understanding non-local connections. We will also discuss historical and contemporary experiments, including those conducted under government-sponsored initiatives that have suggested the possibility of accessing information remotely. Our goal is to provide a comprehensive and accessible explanation of this hypothesis while adhering to scientific rigor and clarity. The content is designed to be clear and relatable, avoiding unnecessary technical jargon, yet remaining precise and informative throughout the discussion. Join us as we explore the intriguing intersection of physics and consciousness, where traditional limits may be re-examined and new possibilities emerge. Let us proceed openly right now. To understand the hypothesis presented, it is essential to begin with the scientific context from which it emerges. The speed of light is a fundamental constant in physics, approximately 299,792,458 meters per second, and serves as a crucial pillar in Einstein's theory of relativity. This theory has established that no physical object or information can travel faster than light in a vacuum, thereby placing a strict limit on the speed at which causal effects can propagate. This limit has been verified through numerous experiments and remains one of the cornerstones of modern physics. However, the rigid framework of the speed of light is not the only aspect of our understanding of the universe. Quantum mechanics, for example, introduces phenomena that challenge our classical interpretations. One such phenomenon is quantum entanglement, where particles become linked and exhibit correlations regardless of the distance separating them. When two particles are entangled, the state of one particle appears to affect the state of the other instantly, a phenomenon that some have interpreted as evidence of instantaneous communication. Although this does not constitute information transfer in the classical sense, it nonetheless invites reflection on how closely interconnected the fabric of reality might be. In the realm of theoretical physics, ideas such as tachyons, hypothetical particles that always travel faster than light, and concepts like warp drives that manipulate the curvature of space-time also suggest that there might exist frameworks where conventional limits are transcended. While these models remain largely speculative and unproven, they open the door to questioning established doctrines. Similarly, experimental initiatives such as remote viewing have been undertaken to explore whether human consciousness can access or transfer information instantaneously, thereby hinting at potential exceptions to the light-speed barrier. In summary, the scientific context for this discussion is rich and multifaceted. It ranges from well-established theories like relativity to the intriguing, if controversial, observations within quantum physics and consciousness studies. By examining these varied perspectives, we build a foundation for understanding how consciousness, an inherently non-material phenomenon, might operate under different principles than those that govern matter and energy. This broader context sets the stage for exploring the possibility that human thought may interact with the universe in ways that challenge our conventional understanding of space, time, and information. Moreover, the interplay between these scientific concepts encourages us to question the limits that have long been accepted as absolute. The implications are profound, as they hint at a universe more complex and interconnected than previously imagined. By integrating insights from both classical physics and emerging experimental techniques, we expand the framework for understanding phenomena that defy easy explanation. These reflections remind us of the boundless potential for scientific discovery and the evolution of understanding, indeed. The central hypothesis under examination posits that human consciousness may operate in ways that allow for the exchange of information in a manner that surpasses the traditional limits of physical communication. Our internal mental processes, which involve complex interactions between memory, perception, and thought, seem to function instantaneously, regardless of the geographical separation between the subject and the object of thought. This observation leads us to question whether such internal processes could be analogous to a form of information transfer that is not confined by the speed of light. In our everyday experience, when we think of a distant star or recall a memory from faraway places, the mental image materializes immediately in our minds. There is no perceptible delay, unlike the finite time required for light or other physical signals to traverse immense distances in space. This stark difference between the perceived rapidity of thought and the measured speed of physical phenomena suggests the possibility of two distinct domains of information exchange, one governed by physical laws and the other by the abstract workings of consciousness. The hypothesis further suggests that the mechanisms underlying human consciousness might share similarities with non-local connections observed in quantum mechanics, particularly quantum entanglement. While entangled particles exhibit correlated behavior regardless of spatial separation, it is conceivable that consciousness might harness a similar principle, thereby enabling a form of instantaneous connection with various aspects of information. Under this framework, the act of thinking could be viewed as engaging with a non-local field of information where the usual constraints of space and time do not apply. Additionally, research into phenomena such as remote viewing provides anecdotal evidence that supports the idea of non-local information access. Such experiments imply that the human mind may possess capabilities that allow it to obtain information from distant locations without relying on conventional sensory inputs. When considered together, these observations form a compelling case for further investigation into the possibility that consciousness could facilitate a mode of information transfer that operates at speeds beyond that of light. This hypothesis challenges the conventional distinctions between physical and non-physical realms and invites us to reconsider the boundaries imposed by established scientific theories. Furthermore, the possibility that consciousness engages with a non-local field of information prompts us to explore deeper philosophical questions regarding the nature of reality. If human thought indeed accesses data through mechanisms that transcend physical limitations, then the implications extend beyond traditional physics and into the realms of metaphysics. This hypothesis calls for interdisciplinary inquiry, integrating insights from neuroscience, quantum theory, and cognitive science, and challenges us to expand our understanding of what it means to know and perceive the world around us. Quantum entanglement is a well-documented phenomenon in which pairs or groups of particles interact in ways that the state of each particle cannot be described independently of the others. Their properties become correlated such that the measurement of one instantaneously determines the state of its partner, regardless of the distance between them. Although this phenomenon does not convey usable information in violation of the speed of light, it represents a striking example of non-local connections in the physical world. Remote viewing experiments have aimed to explore whether human consciousness can similarly access information from distant locations. Initiated under various government-sponsored programs, these experiments sought to determine if individuals could accurately describe or perceive environments that were hidden from their direct sensory input. Despite mixed and often controversial results, several instances have been reported where remote viewers provided descriptions that corresponded with objective details of locations they had never visited. Such accounts suggest a potential for connection that defies conventional explanation. Both quantum entanglement and remote viewing challenge traditional distinctions between locality and non-locality. While quantum entanglement operates within the precise mathematical framework of quantum theory, remote viewing is observed as a subjective experience with anecdotal support but limited empirical validation. However, the parallels are intriguing. Where quantum entanglement demonstrates that state correlations can occur instantly, remote viewing suggests that the human mind might also engage in a form of information exchange that does not adhere to spatial limitations. In analyzing these phenomena, it becomes evident that they share a common theme, one of interconnectedness that transcends conventional boundaries. The instantaneous correlations in quantum physics and the purported immediate access to remote information both invite us to reconsider our understanding of how information might be transmitted or accessed beyond classical physical means. While significant skepticism remains regarding remote viewing, its persistence as an area of study underscores the need for open inquiry into unexplained phenomena. Taken together, these supporting phenomena provide a basis for further investigating the possibility that consciousness might exploit similar non-local mechanisms as observed in quantum systems. By drawing on both scientific evidence and first-hand experiential accounts, a broader picture emerges that challenges the absolute limits imposed by the speed of light, prompting us to reconsider the potential capabilities of the human mind in an interconnected universe. Furthermore, these phenomena encourage a reconsideration of our understanding of reality itself. The interplay between objective scientific measurement and subjective human experience highlights an area ripe for exploration. Both quantum entanglement and remote viewing serve as reminders that the universe may hold secrets far beyond current scientific paradigms, prompting us to explore interdisciplinary approaches for new insights, indeed, profoundly. While the hypothesis of faster-than-light information exchange through consciousness is intriguing, it faces significant criticisms and limitations. Many critics argue that the evidence supporting phenomena such as remote viewing is largely anecdotal and lacks the rigorous reproducibility required by the scientific method. Skeptics contend that the experimental protocols in such studies are often flawed, leaving room for alternative explanations like statistical anomalies or cognitive biases. Consequently, there is widespread skepticism regarding the validity of these claims within mainstream scientific circles. Furthermore, attempts to measure or quantify consciousness remain in their infancy. The subjective nature of human thought makes it exceedingly difficult to apply standardized measurement techniques. Without clear objective metrics to evaluate the speed or mechanism of thought processes, the hypothesis remains largely theoretical. This lack of empirical data hampers efforts to construct a robust theoretical framework that could definitively demonstrate how non-local information exchange might occur. In addition, the integration of quantum phenomena with the processes of human consciousness remains speculative. While quantum mechanics presents well-documented instances of non-local interactions, applying these principles to the realm of consciousness is a significant leap. The complexity and nuance of both fields mean that direct correlations are challenging to establish convincingly. Critics argue that such attempts may inadvertently conflate metaphor with literal scientific explanation. It is therefore important to maintain a clear distinction between empirical evidence and theoretical speculation, ensuring that rigorous standards of proof are upheld. Moreover, these criticisms highlight a broader challenge within both scientific and metaphysical inquiries. It is essential to remain open to new evidence while also demanding rigorous proof. Only through careful scrutiny and balanced investigation can we hope to arrive at a more complete understanding of these complex phenomena. Such reflective analysis is vital for advancing meaningful dialogue and progressive research with rigor and open minds. Despite the challenges and criticisms, it is important to consider ways to expand our scientific framework to include phenomena that currently defy classical explanation. History is replete with examples of theories that were once dismissed as impossible, only to later revolutionize our understanding of the universe. The development of quantum mechanics, string theory, and even early ideas about the origins of consciousness all began as hypotheses that challenged existing paradigms. In this spirit, bridging the gap between physics and consciousness involves acknowledging the limitations of traditional scientific methods when applied to non-material phenomena. Emerging interdisciplinary research suggests that the mind may utilize mechanisms that are not yet fully understood within the confines of conventional physics. By integrating insights from neuroscience, quantum theory, and cognitive science, researchers can begin to construct new models that account for both physical and non-physical dimensions of existence. Such an expanded framework does not negate the importance of rigorous scientific inquiry. Instead, it calls for openness and innovation in both experimental designs and theoretical approaches. It encourages the scientific community to explore novel methods of investigation that can capture the nuances of human thought, perception, and remote information exchange. In doing so, we may uncover answers to questions that have long eluded us, ultimately leading to a deeper understanding of the cosmos and our place within it. Furthermore, the pursuit of bridging physics and consciousness is a dynamic process that necessitates unconventional thinking and persistent experimentation. This approach fosters collaborative efforts across multiple disciplines, encouraging the exploration of phenomena that lie at the intersection of science, philosophy, and holistic inquiry. It serves as a catalyst for innovative breakthroughs that may ultimately reshape our understanding of reality. This pursuit stands as a testament to human curiosity and the endless quest for knowledge, propelling science ever forward tirelessly. In conclusion, the exploration of faster-than-light information exchange through consciousness represents a bold and thought-provoking hypothesis that challenges established scientific boundaries. Although the speed of light remains a fundamental limit for physical communication, the unique nature of human thought suggests that non-local modes of information access might exist beyond conventional frameworks. This discussion has examined the underlying principles of modern physics, investigated parallels in quantum phenomena, and considered experimental evidence from remote viewing studies, as well as the broader implications of consciousness research. While considerable skepticism persists and many challenges remain in providing empirical evidence, the hypothesis invites well-reasoned inquiry and interdisciplinary collaboration. It calls on researchers to remain open-minded and innovative in their approach to phenomena that blur the line between the physical and the metaphysical. By doing so, we may begin to unravel new dimensions of understanding that bridge the gap between hard science and abstract experience. Moreover, this discussion serves as a reminder that progress in science often comes from questioning established doctrines and exploring ideas that initially seem counterintuitive. As our methodologies evolve and our experimental techniques improve, we may find that the boundaries between physics and consciousness are not as rigid as once believed. Ultimately, this hypothesis not only stimulates scientific debate, but also expands the horizons of human inquiry, urging us to re-examine the fundamental limits of the universe. Let this exploration be a catalyst for future research and a testament to our relentless pursuit of knowledge. It encourages us to critically evaluate the nature of reality and invites continuous dialogue on the intricate relationship between mind, matter, and the cosmos. These concluding reflections are not an end, but a beginning for renewed inquiry and scientific innovation. With thoughtful exploration and collaborative research, new paradigms may emerge that reshape our understanding of reality.